All right. Okay, we should be live here or recording, maybe not live. So I'm just going to do a super easy leak code. This is going to be in Python 3. Boy, it's been a few months since I've done any leak code, I think. So just to try to warm up a little bit here, this is a really easy one. Divisible, non-divisible, sums difference. So yeah, so this one, you're given two integers as the input, n and m. N um, and then you further define two more numbers. So number one is the sum of all integers in the range from 1 to n, and we're given n. So we just have this big list. So say we get like 7, then it'll be 1, 2, 3, 4, 5, 6, 7 that are not divisible by m. So let's say it's the, well, let's say it's like, well, we'll just use their example. Okay, so n equals 10, m equals 3. So then we would have this, let's just sketch it out here. So we would have this list. So we'd have, 1, 2, 3, etc. And then we say for each of those, like, is 1 divided by divisible, like cleanly divisible by 3? Like we're like, I guess we do modulo, right? Like n, like 1 modulo 3 equals 0. And that will be the sum, okay, the sum of all okay, so it's whether we include it or not in the list. So we're going to have some, we're going to have basically two accumulating sums. So at num1 plus equals, the thing. So let's say, so we do like, let's say it's 1. So n is 10, 1 through 10. So let's say it's 1. So is 1 cleanly, is 1 not divisible by m? Well, yeah, it's not cleanly divisible by m of 3. So we would add that to the list. So num1 plus equal 1 for our first operation. And we keep doing that, and then we would get to 3. So for number 3, this would not be added to num1. So we'd skip it, right? But for the other list, or it's not really a list, it's an integer, but for num2, we would add that. We would plus equal 3, because 3 is cleanly divisible by 3. So we go through that, and then by the end, we'll have some numbers. And presumably, it's pretty much, I don't know about always, but a lot of the time, I think num1 is going to be bigger than num2. And so you're generally going to get a positive integer at the end, because they want us to subtract num1 minus num2. So at the end, we might have like 37 minus 10 equals 27, and we return that 27, something like that. So that's pretty simple. Now, I'm going to solve it like a naive way first, and then I'll see if I can optimize it. That's usually what I do. So we get n and m here. We've got this type hinting annotation stuff here. So, okay, so let's just say, I think we want to define these first. So num1 equals 0. And actually, I mean, you can be cute and do this kind of thing. I don't like doing that. I like to be really explicit and just do this. So we define these two, and these are kind of, it's basically like an accumulator sort of pattern, right? And so if you're using like JavaScript or something like that, you could do like a reduce, some kind of reduce function or whatever. But we'll just try to keep it simple here. And then we'll say, now I think we're going to do like a for in range type of thing, like, right? So like for I in range n, and so we'll loop through n. Does that make sense, right? I think that'll make sense. And actually, we can do some testing too. So like, let's just say print I. For I, well, actually, I don't know if I want to use I. I think we want to say for number in range n, because I is usually like an index, which is not what we're doing. So we want to be really clear. So let's just like run this and make sure that we're, starting off on a good stage, or a good foot. Okay, so we can already tell it's not going to work because it's 0. It's 0 indexed, which is what range is returning. So now, I actually don't, can you do this for number plus 1? I don't think that works, but I'm just curious to see if that works. Yeah. We can't do an expression. Okay. I thought it probably wouldn't work, but we can do, is there a better way, range in? Well, we could maybe, if we add the +1 here, does that make sense to add the +1 here? Because then we should get, oh no, we don't actually. Oh no, that doesn't make any sense. Because that's gonna be the wrong number. Anyway, we're just gonna have to do an offset thing. Okay, so for number in range, and it's super simple, right? If if number modulo m equals 0, or not equals 0, we'll just do it in the order that they list here. If number modulo m not equal to 0, so if it doesn't cleanly divide, then we're going to say num1 plus equal, take whatever it is and add it and make a new number. We add the number, right? And then we can just kind of copy paste this. If number is divisible, then we want to do num2. And then I think we just like return num1 minus num2. I mean, it's really simple problem, obviously. I mean, that is what it is, right? We might find some edge case or something, though. It's the wrong answer. Okay, so we output 9. We expected 19. So we're doing something wrong. Okay, so what are we doing wrong? So num1. So this is that example test case. Okay. So we're expecting 19. Okay, so for number in range. Oh, duh. Remember we had the +1 thing. Now how do we handle this if number? This is really annoying. I hate the offset thing. So for number in range, what if we just is there a better way to just make a list, probably like a list comprehension for number in, can't we just do like, is this crazy? Like, wait, how does this work? For number in, how does this work? How do we make a list comprehension where it's 1 to n? As I know, there's like Haskell and stuff where you can just do that, which is really handy. Or either, I mean, I don't know if that's the exact syntax, but there are some languages where you can just really do it easily. And my Python is a little rusty here, so I'm not totally remembering. Let's see here. Let's go ahead and do a little research here. Okay, so let's say, hey, I am thinking to do a list comprehension in Python 3 where I could get 1, 2, n for a given n. I am spacing on the syntax. Help, please. Concise answer. I don't want to like read some huge thing right now. Ooh, that's really big text. We can probably shrink that a little bit. So, that's kind of ugly. Isn't that kind of ugly? I for I in range 1. Oh shit! Oh, sorry, I don't mean to use naughty language here. Okay, so we can just, the range function accepts a starting number. Let's just do that. That's so much easier. Okay, so now I wonder if our test will pass. Uh-oh, nope, that's still not right. What the heck is going on here? In range 1 n. Okay, let's I wish I had the REPL. I need like the REPL thing here. Wish you were built in, you know? Python 3. For I in range 1, say 10. Print I. That does 1 through 9. Oh. Oh, interesting. So if we want, so it doesn't do the last number. So I guess we're gonna have all kinds of funky exceptions. So I guess if we do a +1 at the end, so n plus 1. Now I think this will be correct. Yep. Okay. So all these test cases. Now, if I submit it, because you can run it and it just does a few test cases, but if you submit it, it does so yeah, it does 737 test cases. Okay, so that's cool. Yeah, it's always like these off by one things you got to deal with, because range by default is not going to do the last, or it's exclusive, not inclusive. But our logic here is sound. Now, I think this, I don't think we get any simpler than this, right? This is an O of n kind of problem. You're going to have to go through every number 1 up until n, right? I don't think there's any, and we're just going through the list exactly once. We don't have any nested loops. I don't think it really gets any simpler. Now, you might be able to have cute little syntax to shrink things a little bit. Like we could do a ternary type of thing to get fewer lines or whatever, but I mean, that doesn't really actually do much for us. So I think, I don't think we can improve the speed or the time complexity or space complexity of this, right? I mean, you're going to have to keep track of these two numbers. You're going to have to go through a list of integers for 1 to n. You're going to have to do this subtraction. I mean, really, the bulk of the compute is happening here, and I don't. There's no way to cheat it. It's not like it's one of those where you say like, oh, square root of n so that we can shrink the number of things we check. I mean, it's I don't think it's like that. Is there anything we can save time? Like, I don't know if we can. I don't know that we can save time at all. I really don't think you can improve on this in terms of time complexity or space complexity. So I'm going to paste it in my thing. I'm going to say time O of n. I like to just try to write this down. Space is, I think it's honestly like O of 1. I think it's like O of 1, because we're not actually, I think this is like a lazy loading kind of thing with range. I don't think it's creating, I don't suspect it's creating and storing a new list. I think it's just kind of as needed. I'm pretty sure about that. Let us, oops, wow, we missed a number there. So, oops, and I'm doing this inside my template. I'm sorry. Okay. Let us copy. I like to copy my template here, and then use that. Actually, let me shrink that. Sorry for all the paperwork here. Okay. So let's paste that in here, and then let's grab the URL, which is this one. And then, okay, so my solution, not very exciting, sorry. Okay, and then like I say, I think it's O of n. I mean, I think that's pretty clear. I suspect this is O of 1. It keeps wanting to drop that last character too. Let's ask Gemini here. Oh, where's Gemini? Where'd Gemini go? Gemini. Is my solution, okay. Time and space complexity estimates correct here. Yeah, let's see what it says. Optimization. I don't want an improved solution. I'm just, oh my God. Okay, so O of n is accurate query for the for loop 1 to n, exactly n times. Yep. Operations are all constant time operations. They take a similar amount of time regardless of input size. Okay. So n times O of n. Okay. It's also spot on. If you're using a few variables to store integers, sure. The amount of memory required is fixed and does not increase as it gets larger because your algorithm memory is constant. Okay, cool. Well, I don't want to hear about your optimal approach just yet. Let's see. There's accepted. We can look at the solutions tab probably. Solution. What is this? Oh, this is just like their. Sorry, what is all this? Oh man, this is something else. Okay, how do we get to the solutions tab? They've changed their interface a bunch since I've. Okay, math in depth. In depth. Oh, give me a break. Python 3. Let's filter it down. Beats 100%. Okay, so what is this? Brute force. Oh, what is this? This is not Python. This is not Python. Arithmetic progression. Python 3. Okay. Answer is given by the formula. Okay, so there's the math formula. For for O1 solution, use this. Time complexity O1. Well, okay, we definitely didn't have the optimal. One-liner. Oh, geez, this is so hard to read. Okay, it's n times n plus 1 divided by 2. It's basically recreating the equation, I think. That's not very helpful. Num2. Boy, yeah, this is really hard to read. So it's given by the formula. Yeah, I'm not even sure about that. Okay. Okay, calculate, blah, 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 blah. Naive solution. Yep. And iterate, yada, yada. That was obviously our solution. Optimized solution used in our code. We avoid looping altogether using mathematical formulas. Total sum from 1 to n is n times n plus 1 over 2. Count the number divisible by m. And sum of the numbers divisible by m forms an arithmetic series. Then the result is a sum minus dm. Okay. So, okay. So the total is n times n plus 1 over 2. And we divide, and then division sum equals, oh my gosh. Let's walk through with examples. Sum, number 1 over number 2. Divisible by 3? No. So num1 plus equal 1. Num1 plus equal 2. I mean, we already know all this. This is not. Final values result. It's just kind of like, it's one of these math ones. I don't like these. Okay, well, let's see here. What does Gemini say? More optimal approach. The mathematical formula, which avoids looping entirely. It's just so cheesy. I really don't like problems like this where it's just some math problem. It's not really computer science at that point. It's just knowing a trick. It's just a trick, right? That's annoying. Calculate the sum. The logic is calculate the sum of all numbers 1 to n. Calculate the sum of all numbers 1 to n that are divisible by m. Final result, right? This is just for your information. Total sum minus 2. Okay, so what would Python 3 code look like for the math version of things? Yeah, we may as well like paste that in. I really hate these ones that have these little math problem solutions. Okay, so solution, okay, difference of sums. Calculate the sum of all numbers from 1 to n. Sure, well that's easy enough. Formula for sum of the first n integers is n times n plus 1 over 2. So that's just a straight formula. That's just a math formula. Sum of all integers 1 to n is just n times n plus 1 over 2. So let's do an example here. Okay. do an example. So, like for sum of all numbers, let's say 1 to 5. So that's 3, 1 plus 2 plus 3 plus 4 plus 5. So that is 15, okay? So n is 5. So 5 times n plus 1 is 6 divided by 2 is 15. Oh yeah, it works. Cool, neat. Find the number of integers from 1 to n that are divisible by m. This is equivalent to floor of n divided by m. Okay, so in our test example thing, it's like 10 divided by 3 and the floor of 3. So that's k is 3. Oh, I see the number of integers 1 to n. So it's not saying like which ones or anything, it's just the number. So that's just a mathematical fact, apparently. Okay? And then calculate the number of numbers divisible by m. This is the arithmetic series. Okay, arithmetic series m plus 2 times m plus k times m equals m times 1 plus plus k. 1 plus 2 plus 3. We use the sum formula again for the series 1 to k. Sum of multiples equals m, which in our example is 3, times k plus 1 divided by 2. Okay, so I need to like I need to see this, like 3. Okay, so 3, and the k is k is also 3 in this case. Okay, so 3 plus 1 is 4. 4 times 3 is 12. Divided by 2 is 6. 6 times 3 is 18. But we had wasn't it 9? The answer was 19, right? So, and they said the floor though. So 3 plus 1 is 4. Times there's 12. 6. Well, how do we get 18? The final result is, so this is 18 apparently. This is I think, well, for the 10 example, it's 11 times 10 divided by 2 is 55. So the final result is 55 minus 2 times 18. 55 minus, okay, so it would be 2 times this sum of multiples, which is 18, so that's 36. So it's our total sum, 55 minus the 36, which gives us the 19. So it's just a lot of mathematical facts, I guess, and it's taking advantage of this arithmetic series. So we get the total, and then we do this arithmetic series, and then we do this special formula. It's just a lot of special formulas, which is not very satisfying. But in any case, I'll go ahead and paste this in here. That was not a very fun one, I have to say. I hate ones that rely on those math tricks. So and this is I'm going to write a note here. So this solution uses math formulas to mathematical formulas to do time complexity of 1 instead of n. Yeah, that's annoying. It's just dumb. But whatever, it is what it is. Anyway, thank you for watching. I doubt anyone watched this whole thing. I doubt anyone watched this at all. But that was some good practice just to kind of work on our Python and stuff. Like this was good, like the range of 1 to n plus 1 to get that 1 to n series. That's pretty cool. The math stuff is just dumb, but you know, we still got some good practice with Python, and we also got some good practice thinking about time and space complexity. So it's still good practice, even if the you know, problem itself was kind of silly. Anyway, thank you.